The James Webb Space Telescope has gave us a peek of some amazing photos as it looks back toward the beginning of everything. Astronomers and scientists are fascinated by this telescope's discovery, which questions our understanding of the universe. This discovery raises the possibility of a monumental event that could completely alter the way we understand the cosmos. This discovery is extremely significant and raises questions regarding the fundamentals of our cosmic existence. It begs the question, might this find spell the end for everything we know? Is something profoundly different from what we now understand about the cosmos about to happen? Come along as we examine how the most recent discovery made by the James Webb Space Telescope might alter our perception of the universe. Examining the observable universe, our window into the wide beyond, is how we start our adventure. All that our telescopes and space missions can detect, measure, and investigate is included in the observable universe. It is a group of stars, galaxies, and other celestial bodies that are visible to us and make up a very small portion of the total universe. A small part of a very large cosmic puzzle that people are trying to study and understand. The overall shape and scale of the cosmos are still unknown despite our advances. It is estimated that the observable universe has a diameter of about 93 billion light-years. The distance that light can travel in an Earth year is one of the many factors that contribute to this astounding number. With an estimated 13.8 billion years having passed since the Big Bang, the observable universe is thought to have a diameter of around 93 billion light-years and extend 13.8 billion light-years in all directions from Earth. But according to Hubble's law, space has been expanding ever since the Big Bang, which has caused the observable universe to expand as well. According to current estimations, things that were 13.8 billion light-years away from Earth when they first began to emit light 13.8 billion years ago are now roughly 46 billion light-years away. The observable universe appears to be expanding beyond 46 billion light-years in all directions from Earth. Based on this expansion, the cosmos is expanding and accelerating due to a massive explosion that occurred billions of years ago that started the cosmic expansion. This acceleration appears to be driven by enigmatic factors, such as the unexplained dark energy, which is pushing the boundaries of the cosmos farther apart. Gravitational forces drew particles together as the universe expanded, creating magnificent formations like stars, galaxies, and planets, including our own Earth. Notwithstanding the universe's vastness, technological progress has made it possible for us to continuously discover new areas of the cosmos. The public may now see far-off stars and galaxies thanks to specialized telescopes like the Hubble Space Telescope and the James Webb Space Telescope, which have made these marvels easier to comprehend. Upon reflection of the vastness of space, it is noteworthy that the universe seems oddly barren even inside our massive solar system. Even if the closest star were reduced to the size of a quarter, its distance would remain approximately 2 soccer fields. This majesty stretches slightly within our Milky Way galaxy, which is one of the billions of galaxies in the visible universe, providing us with an idea of how enormous the cosmos is. Further issues concerning the nature of our existence and the possibility of cosmic-scale transformative events arise as we continue our exploration in light of the recent discovery made by the James Webb Space Telescope. You may wonder why it is that humans are unable to see the entire universe. This constraint arises for multiple reasons. Even though light travels through space at the fastest speed in the cosmos, it still takes time. As a result, looking at far-off objects is like looking backward in time. As we observe galaxies millions, if not billions, of light-years distant, the farther an object is, the longer its light has traveled to reach us, forming a kind of cosmic time machine that reveals the history of our universe. The expansion of the cosmos is another important force at work. Imagine the surface of an inflated balloon that is covered in dots. The dots will spread apart as the balloon expands. In a similar way, as space expands, galaxies move apart. Redshift is the result of this expansion, which causes the light generated by far-off objects to change and its wavelengths to stretch toward longer, redder tones. After a certain amount of time, some celestial bodies pass the cosmic horizon, where the universe's continuous expansion causes their light to be too far away for us to see. It is not unexpected that we haven't viewed the entire universe yet, given these two important factors: the expansion of the universe and the speed at which light travels through space. The basic characteristics of the universe continue to limit human perception, even with the most sophisticated telescopes and technologies. Let's explore these ideas in more detail. Measuring the distance light travels in a year in light years, the universe's immensity is astounding. The Milky Way galaxy is approximately 100,000 light-years in length. Proxima Centauri, the star closest to our solar even within our galaxy, is around 4.24 light-years away. We can see galaxies billions or millions of light-years away when we look into space, which gives us insight into the early history of the cosmos. People from different areas have been fascinated by the enigma surrounding the boundary of the universe. Although there are still no clear answers, three important possibilities have been proposed. According to the first, the universe is infinitely big and eternal, extending endlessly in all directions without an apparent end. The second picture is of a finite universe with no sharp boundaries, like a vast spherical or curving expanse. As in the case of this situation, going indefinitely in any direction would eventually return one to the beginning, just like going around the Earth would. The idea that there are multiple universes, each with its own unique set of physical laws and characteristics, is presented in the third hypothesis, sometimes known as the multiverse concept. These universes might function alone or together, creating a huge, complex multiverse. Examining these possibilities piques the curiosity of philosophers and scientists alike. The idea of an infinite universe contradicts our understanding of space's size. On the other hand, a finite universe without an edge casts doubt on our understanding of continuity and boundaries and raises the possibility of cyclical patterns in the structure of space. The hypothesis of the multiverse, with its parallel universes, suggests realms that are very different from our own, opening up possibilities beyond what we can now comprehend. It's important to remember that these ideas are still theoretical and elusive and need more research. There are several obstacles in the way of exploring the edge of the cosmos, which makes it challenging to conclusively confirm or refute current theories. Uncovering the mysteries surrounding the universe's boundaries is made more difficult by the immensity of cosmic space and the limitations of our observational tools and technology. But in the middle of this cosmic ambiguity, the James Webb Space Telescope stands out as a ray of hope, offering to provide insight into the mysterious origins of our universe. Among the tools that can change the game is the James Webb Space Telescope, which provides the most accurate image of the universe. With the use of this special tool, we may be able to solve the mysterious past of our universe and gain knowledge that was previously unthinkable. The JWST, a technological marvel, has produced significant discoveries lately, especially in its exploration of the edge of the universe. Among the amazing discoveries is the discovery of 6 huge galaxies that are 500 to 700 million years old, or more, after the Big Bang. This study, which was published in the journal Nature, casts doubt on accepted notions regarding the genesis and evolution of galaxies in the early universe. Remarkably, these old galaxies show diameters far larger than one would anticipate for their age, which contradicts expectations and changes the story of cosmic evolution. Instead of expecting to see tiny, incipient galaxies, scientists were shocked to find these enormous cosmic objects. These old galaxies are remarkably mature, akin to our Milky Way galaxy, which is 13 billion years old. The stars in these massive galaxies have an unfathomable total mass. Some galaxies may have as much as 100 billion times the mass of the Sun in their stars. The JWST uses infrared light, which is invisible to the human eye, to observe the mysteries of the cosmos with unsurpassed ability. With the help of this capacity, the telescope may identify traces of cosmic debris that have lasted for billions of years by detecting weak emissions from ancient stars and galaxies. Acting as a time machine, the JWST projects our perspective back in time, offering priceless insights into the universe some 13.5 billion years ago. The finding of massive galaxies, known as universe breakers, in recent times has completely changed our knowledge of the evolving universe. These surprising results cast doubt on long-held theories and the widely accepted notion that galaxies began small and gradually changed over time. Beyond all expectations, the James Webb Space Telescope has been instrumental in revealing the mysteries of these huge galaxies through the use of spectroscopic techniques and high-resolution pictures. The cosmos is further complicated by the potential presence of supermassive black holes beneath these galaxies. Up to 100 times more stars are known to exist in the universe than previously thought, even when only 25% of the data are taken into account. This finding forces a fundamental reevaluation of our comprehension of cosmic mass and structure. New discoveries add to our cosmic map, providing ever more detailed insights into the origins and evolution of the universe. Beyond their size, the ramifications of these gigantic galaxies are profound, calling into question long-held beliefs and forcing us to re-evaluate how we explain cosmic development. With its state-of-the-art equipment, the James Webb Space Telescope has been instrumental in propelling our understanding of the universe to previously unimaginable heights. The JWST made some amazing discoveries, one of which being the identification of the oldest and furthest off galaxies ever observed. These galaxies take us back in time to a time when the universe was only 400 million years old, having survived the enormous event known as the Big Bang. The fact that the light from these galaxies began its trip more than 13.4 billion years ago and was eventually detected by us using the JWST lens only serves to heighten our excitement. The JWST's first images mirror the early observations made by the Hubble Space Telescope, which show a multitude of potential galaxies. By means of advanced spectroscopic analyses, astronomers were able to validate 4 of these astronomical occurrences, which made it possible to examine their physical characteristics in great detail and determine how far away they were from Earth. Redshift is a notion that is used to calculate the distance between galaxies because, as the universe expands, celestial objects appear to recede from our perspective. The Doppler effect is the result of their light waves expanding and shifting toward longer wavelengths. Although redshift can be estimated using different filters and photos, spectroscopy is the preferred method for getting accurate values. The JWST discovery, which focuses on 4 galaxies with redshifts larger than 10, demonstrates how far away these objects are from Earth. In order to put this into perspective, 2 considerably more distant galaxies with redshifts of 13.10 and 12.63 were discovered by the JWST, whereas galaxies with redshifts of 10.38 and 11.58 had previously been found by the Hubble Space Telescope. A redshift of 13.2 provides an intriguing window into the previous history of the cosmos by effectively implying a time frame of 13.5 billion years ago. The Advanced Deep Extragalactic Survey, JADES, of the James Webb Space Telescope is evidence of the telescope's lofty goals. JADES is an international partnership of about 80 astronomers and scientists from 10 different countries, and it was conceived in 2015 by a group of instrument teams. Their goal is to start a vast exploration of the early stages of the universe in order to solve long-standing puzzles. The implications of the James Webb Space Telescope's discoveries go much beyond simple observations as we examine the cosmos through its lens. In addition to shedding light on the early phases of cosmic evolution, the findings made by this extraordinary device raise important queries regarding the nature of reality itself. The commonly held belief that galaxies must develop gradually over billions of years is called into question by the discovery of these huge galaxies at a time so close to the Big Bang. Rather, the evidence points to the possibility that early universe circumstances may have permitted fast galaxy formation, may be fueled by distinct physical mechanisms that we are now learning about. The capability of the JWST to observe at infrared wavelengths is especially important. Due to the universe's expansion, many astronomical occurrences release light that has been redshifted, rendering them invisible to optical telescopes like Hubble. Primordial galaxies and star-forming regions are among the things that the JWST discovers by detecting this infrared radiation. With the use of this capacity, astronomers can now explore new horizons and learn a great deal about the early stages of the cosmos, including how stars formed and intricate structures initially appeared. Furthermore, the discoveries made by the JWST cast doubt on our knowledge of dark matter, a material that is thought to account for a sizable amount of the mass of the universe but is elusive and challenging to detect. The topic of how dark matter influenced the development of huge galaxies is raised by their presence at such an early stage in cosmic history. It implies that dark matter may have shaped the early universe more actively than previously believed, affecting the gravitational dynamics that resulted in the birth of galaxies. The JWST results not only revolutionize our understanding of galaxy formation, but also provide intriguing clues regarding the prerequisites for extraterrestrial life. These old galaxies may include components like carbon, oxygen, and nitrogen, which suggest that life as we know it has existed for a lot longer than previously thought.